Good afternoon, everyone. I am Madhav from BCA PPU second year batch 1, and today I am going to give a presentation on of subject mathematics, and the topic is linear equation with constant coefficient. We will be watching complementary function and particular integral in this presentation. So there are four methods to find complementary function based on the nature of roots. Like real and unequal roots, we have complementary equation is c1 e to the power ax plus c2 e to the power beta x, alpha x plus c2 e to the power beta x. And for real and equal roots, we have y equal to c1x plus c2 into e to the power alpha x. For complex conjugate and non-repeated roots, we have a complementary function y equal to e to the power alpha x into a cos beta x plus b sin beta x. And for complex conjugate and repeated roots, we have complementary equation of y equal to e to the power alpha x into a1 plus a2x plus a3x plus dot 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 into cos beta x plus b1 plus b2x plus b3x into sin beta x. So we have a question here: d square y upon dx square minus 2m dy upon dx plus m square y equals sin nx. So let's see how to solve this question. So firstly, we will write that auxiliary equation for this given equation. We will replace dy dx with d. So here d square by dx square will be d square, and y minus 2m dy plus m square y equals 0. We will take y common from this equation, so we will have d square minus 2md plus m square equals 0. We will use factorization by middle term splitting, so we have d square minus md plus m square equals 0. We will take d common from these two terms, so we will have d minus m, and minus m common from these two terms, we will have d minus m. And now we will take d minus m common, so we will get d minus m again, and we have roots d equals m comma m, which are real and equal roots. So we have complementary function of y equals c1x plus c2 into e to the power mx, where a alpha equals to m. Now we will see how to find a particular integral. So this is equal to 1 upon fd function of d into sin ax, which is equal to 1 upon phi of d square, where phi of d square is the expression is the polynomial in d square into sin ax. Now we will see, we will replace d square by minus a square. So particular integral will be 1 upon d square minus 2md plus m square into sin nx. Now we will replace d square with a. Here it is n, so it becomes minus n square minus 2md plus m square into sin nx. We will take these two terms together because these are constant, so minus 2md plus m square minus n square into sin nx. Now we have to eliminate this d term, so we will rationalize. So we will get 4m square d square minus m square minus n square to the whole square, and in the numerator we will have minus 2md minus m square minus n square into sin nx. Now we will multiply these two terms, so minus 2md sin nx minus m square minus n square into sin nx upon 4m square, or we will replace d square with minus n square minus and we will open these square terms, so m to the power 4 plus n to the power 4 minus 2m square n square. Now we will solve this. This is d sin nx. We replace d by d with d by dx, so this will become n cos nx. So this will become minus 2m n cos nx minus m square minus n square sin nx upon minus 4m square n square minus, we will open this term, so minus m to the power 4 minus n to the power 4 plus 2m square n square. Now particular integral is equal to, we will take common minus here, so minus 2mn cos nx plus m square minus n square into sin nx upon minus m to the power 4 minus n to the power 4, and we will solve these two terms. So here we will get minus 2m square n square. Again we will take minus common from the denominator, so this will become minus of m to the power 4 plus n to the power 4 plus 2m square n square. Now minus minus cancels out, so we will get 2mn cos nx plus m square minus n square sin nx upon this will becomes m square plus n square ka whole square. So the general solution will be y equal to complementary function plus particular integral. So y equal to, here it is complementary function c1x plus c2 into e to the power mx plus this particular integral part m square minus n square sin nx plus 2mn cos nx upon m square plus n square to the whole square. So that's all. Thank you.